Hi, my name is Alia. I will explain about the enzyme technology overview in the global industry first. Okay, so basically, enzyme is being used in various industry, and it is being used for stain removal, fabric treatment, and food processing and other purposes. And it is related to SDG 9, which is to a sustainable industrial sector driven by innovation, which industries are under pressure for to reduce their carbon footprint. So they are needed to do enzyme technology to reduce and to make it sustainable in industrial practices. So what is the importance of sustainable enzyme sources? As mentioned before, it helps in reducing carbon footprint. So the sustainable enzyme source helps in reducing the carbon footprint and reducing toxic waste with lowering production costs by using agro-waste. So basically, it's relatable to the SDG 12 and SDG 3, which is sustainable consumption and production, and supports safe processing by replacing allergen and harmful chemicals, provide good health to everyone. So basically, it is very important to have a sustainable enzyme source. Okay, next, it's about the promising enzyme source from pineapple peel. So basically, pineapple peel is pineapple itself is one of the largest waste, which is potential to be a valuable product. So basically nowadays they are using pineapple peel, one of the ways, to extract the bromelain enzyme, which is a proteolytic enzyme in the pineapple, to be used in various industries. So it can work in optimum and harsh conditions, which also generally recognized as safe by FDA, which leave no harmful effects towards humans. So it is safe to be consumed. As in Malaysia, current industry status in Malaysia, Malaysia is the top global exporter, one of the top global exporter of pineapple, basically based in Johor, Sabah and Sarawak, the biggest one, and has increased continuously, mentioned by MPIB, which is the Malaysian Pineapple Industry Board. So they mentioned that pineapple peel itself is being used in various applications, and the bromelain enzyme is extracted for production purposes, which now it can reduce the reliance on imported producer. So basically, pineapple peel is now very famous in halal industry, and it's very promising to be commercialized.
Hi, my name is Denishadi, and for this session, I will explain why pineapple waste is a sustainable and industrial viable source of the enzyme bromelain. For the justification, we have three we want to highlight, which is the first one is the pineapple waste as a sustainable source of bromelain. Second is the abundant and year-round supply, and the third is the technological and industrial suitability. Bromelain is a proteolytic enzyme found in the pineapple plant, especially in the core, crown, stem, and peel. Although the core contains more enzyme, it is edible and not considered waste. So our focus is on the crown and peel, which are commonly discarded. According to the studies Good et al. In 2021, the crown gave the highest purification flow at 4.34, meaning it's easy to purify, and the peel give the highest recovery rate, making both excellent candidates for the bromelain extraction from the waste. These align with the SDG 9, promoting a sustainable industry through innovation, using the agro-waste as a resource instead of letting it go to the landfill. In terms of supply, pineapple is considered a non-seasonal fruit, so it's always available all year round. It's also Malaysia's most produced fruit, which is over 537,000 tons in 2022, more than durians or bananas. This means there is no shortage of raw material, and industrial bromelain production can run continuously, as you can see from the figure I put. And lastly, this process uses green technologies like ultrafiltration and freeze drying, which is energy efficient and suitable for rural bio-based industries. This helps stimulate the local SMEs, especially the near pineapple farms, and support low-carbon industry development. In the conclusion, pineapple waste makes a very high offers of bromelain content, reliable supply, and sustainability potential, making it a strategic raw material for the enzyme technology. This is the process flow overview of the extraction of the pineapple. The process of bromelain extraction from the pineapple waste begins with shredding or crushing the waste to increase the surface area for the enzyme release. The crushed material is mixed with a sodium phosphate buffer in a homogenization tank, where bromelain is then extracted into the solution. After that, centrifugation removes solid debris, and the supernatant containing the crude bromelain is purified using two-stage ultrafiltration setup. The first membrane removes larger proteins, while the second one concentrates the enzyme. In a pharmaceutical grade production, additional purification by the ion exchange or gel filtration ultrafiltration chromatography may be applied, and finally the enzyme is then concentrated and dried using the freeze drying or spray drying, producing a stable powder form of suitable for various applications. As you can see here, there is a 9. The main highlights of the process flowchart, which is from the raw material, size reduction, buffer homogenization, solid liquid separation, membrane purification, optional chromatography, concentration, drying, and the last one is the end product, which is in bromelain enzyme will be in the form of powder for the shelf life.
A very good day, Doctor. My name is Vanshi Kumari, and I'll be explaining the downstream process on how bromelain is efficiently extracted and purified from pineapple peel. So after homogenizing the pineapple peel with buffer, the mixture is then centrifuged to remove the solid residues, resulting in a crude enzyme-rich liquid phase. Ultrafiltration is preferred method for initial purification. A 2-stage system is typically used. A 75 kDa membrane removes large particles, followed by a 10 kDa membrane to separate protein mixtures. This approach can recover up to 96% of the bromelain and increases its purity by 1 to 2.5 times. The enzyme pretreatment with pectinase or cellulase is sometimes applied to reduce the viscosity and to improve the membrane filtration, increasing in the filtration flux by 37%, though it may require more diafiltration volume. For higher purity, especially for pharmaceutical application, the extract may undergo absorptive chromatography or like ion exchange or affinity column to remove low molecular weight impurities or colorants. Combining ultrafiltration with chromatography significantly enhances the specific activity of bromelain. The final product is concentrated and freeze-dried, preserving the enzyme's natural activity and yielding a stable powder. I'll explain the technological innovations and optimization. Process intensification combines multiple purification steps, reducing processing time, equipment needs, and cost while improving yield and product quality. For example, integrating enzymic pretreatment with ultrasound-assisted extraction, also known as UAE, increases mass transfer and cell disruption, leading to higher bromelain recovery and activity, especially at lower temperatures that prevent enzyme denaturization. The next one is membrane process allow for efficient removal of unwanted particles and enzyme centrifuge in a single step, eliminating the need for salt precipitation and repeated centrifugation. This streamlines the process and reduces chemical use. The next one is integration of ultrafiltration and chromatography, means fewer steps and higher enzyme quality, as both concentration and purification are achieved for more efficiency. Lastly, continuous flow extraction systems are being developed for large-scale, efficient production. These systems enable continuous operation, better process control, and improved reproducibility, aligning with the principles of process intensifications. Next, I'll explain the energy and waste reduction. So, non-thermal extraction methods, UAE or MEE, use less energy and traditional boiling, operating efficiently at lower temperatures and shorter times. Membrane filtration replaces energy-intensive steps operating at mild pressure and temperatures, and can be reused for long-term savings. Enzyme pretreatment not only improves extraction efficiency but also reduces the amount of solid waste by breaking down complex carbohydrates, making the process more sustainable. Waste valorization is practiced by repurposing residual biomass at animal feed, compost, or for bioethanol production, supporting a zero-waste approach. And lastly, closed-loop water systems minimize water usage and wastewater output during washing, extraction, and diafiltration. That's all for my part. Thank you very much.
Assalamualaikum, my name is Muhammad Zakhan bin Muhammad Ali. In this presentation, I will explain about the safety, ethical and societal consideration and also the challenges in industrial implementation. The first one is safety consideration. There are 2 points highlighted, which are the raw material handling and the chemical handling. Along the entire extraction process, safety is a crucial part because pineapple has a sharp edge and the knife that used to cut the pineapple into small pieces also have a sharp blade. Therefore, when handling pineapple waste, it is important to wear a protective equipment like cut-resistant gloves and lab coats to prevent injuries. During the extraction and purification process, there are some chemicals used such as ammonium sulfate and sodium acetate. This chemical is harmful and can be dangerous if exposed in a long period of time. So it is recommended to wear appropriate PPE such as gloves, masks, and safety goggles. And chemicals must be handled in well-ventilated areas with proper waste disposal. From the ethical point of view, using pineapple waste can promote sustainable development by reducing the environmental impact and encouraging green extraction technologies. It is essential that all the bromelain products are tested for purity, efficacy, and safety before reaching to the consumers to ensure its scientific integrity. Moreover, fair benefits sharing with local farmers and communities helps promote social justice and respect traditional knowledge, fostering trust and sustainable livelihoods. Last but not least, the societal consideration in order to produce the bromelain. Bromelain production supports rural development by generating employment and additional income for local communities. Its natural and affordable health benefits make it an attractive alternative to conventional medicine, which is improving the public health outcomes. In addition, converting pineapple waste into valuable products also can reduce the landfill use and overburning, thereby decreasing the pollution and promoting sustainable agriculture practices. Move to the challenges in industrial implementation. The first challenge is the regulatory. It requires strict compliance with FDA regulation, which is Food and Drug Administration, including classification as generally recognized as safe (GRAS) and adherence to good manufacturing practices (GMP) to ensure the product safety and quality. This involves comprehensive documentation and safety testing, which can be complex and time-consuming. The next is the technological challenges. It includes low yields and inconsistent enzyme activity during the extraction and purification process. Bromelain is sensitive to temperature and pH, making it difficult to maintain stability. Therefore, advanced and cost-effective bioprocess technologies are needed to improve the yield and maintain the enzyme quality. The last challenges is the socio-economic challenges, which involve the cost of collecting, transporting, and processing pineapple waste, which can be affected by seasonal availability and geographic factors. Engaging local farmers and integrating waste management can help secure a steady supply of raw materials. However, consumer acceptance of enzyme derived from waste remains a hurdle due to perception issues, requiring education and transparent communication to build a trust. That's all for me. I will pass it to my friend Priya to continue the presentation.
Thank you, Ease. My name is Priya. Now we are going to explore the future direction of pineapple waste. Did you know the pineapple peels, crowns, and stems, once considered waste, are now the starting point of high-value innovations? Through zero-waste technology, researchers are transforming pineapple biomass into functional products across food, pharmaceutical, and energy industries. The key component bromelain is being extracted into enzyme-rich powders for use in digestive aids, meat tenderizers, and anti-inflammatory treatments. But the impact does not stop there. Thanks to high sugar content and bioactive component pineapple waste, we can now produce bioethanol, bioplastics, prebiotics, bioadsorbent, and even vinegar and wine. Cellulose extracted from waste peels is also being used in green packaging and textile application. This solution reduces landfill disposal, cut greenhouse gas emission, and promotes a circular economy, turning agricultural byproducts into eco-friendly assets. Looking ahead, one of the key areas for future research is shelf-stability. Bromelain loses up to 90% of its enzymatic activity within a month at 27 degrees Celsius, affecting the potency of derived product. Therefore, future efforts must focus on understanding of how storage condition, degradation kinetics, and downstream processing influence shelf life, ensuring that the extracted bromelain remains effective throughout its intended use. To support true sustainability, the researchers are also applying life cycle assessment strategies to evaluate the environmental and economic impact of every step in the production chain. In parallel, advanced conversion techniques are being developed into extract prebiotics, phenolics, organic acids, and ethanol, expanding the use of pineapple waste in pharmaceutical, food, and textile, and clean energy. Ultimately, this growing field supports Sustainable Development Goals 9, driving innovation and helping industries transition towards low-cost, zero-waste future powered by something as simple as pineapple waste. That's all from us. Thank you.